Okay, let's start. Welcome, everybody. My name is Bruno Lowagie. Sitting next to me is Raf Hens. We're from INTEC Software, and today I'm going to talk PDF, whereas Raf is going to talk Java. Now, the title of our session is PDF is dead, long live PDF. And the question is PDF really dead? Well, looking at my copy of the reference manual, you would say yes, because, or you could say Bruno doesn't like PDF because he tore his manual in two. But actually, I used that book that much that it fell apart on its own. Now, PDF is dead. Why are some people telling this? Well, because everybody seems to be using HTML. If you look at the internet, you see that, on commercial sites, on .com sites, 98% of the documents that are presented on the websites are, in fact, HTML or HTML-like files, like PHP or Java-generated HTML. But if you look at specific types of sites, like .org, .gov, .edu, you see that the percentage of HTML is much lower. These numbers, by the way, are compiled by Duff Johnson. Duff Johnson is one of the team leaders at the ISO committees for PDF. And now, if we look specifically at the .org, .gov, and .edu numbers, you see that, well, in millions of files, that we have about, well, between 600 million and 700 million files on .org sites. And you see that 15% of them are actually PDFs. And the percentage of PDFs is the highest for government sites, like 38%. And on .edu sites, 27%. Now, why this difference? What is different on governmental sites, on educational sites, from .com sites? Well, on .com sites and the internet in general, you have a lot of publications. So publications, they don't need to be self-contained. They may change over time. For instance, on a news site, you have a scoop with a headline, and then as the story evolves, the page changes. And not all the content in a publication is produced by the author. For instance, on a website, you have ads or comment sections. Like publications are also becoming more interactive. You have comments on a news article or contributions by people who don't own the website. Whereas documents, a document is a piece of written, printed, or electronic matter that provides information or evidence that serves as an official record. A document needs to be self-contained. If you make a contract, if you have like a diploma, it's not supposed to change. So it's non-dynamic. You also need to be able to know who wrote the document. Like if you obtain a diploma from a university, it's important that the people you share the diploma with know that it's actually the university where you studied that issued the diploma. You also need to be sure that the document can be secured or protected so that it doesn't change over time, like a contract where you promise somebody to pay him like $100 an hour, you can't change it to a 50 or a 150. So there's a difference between documents and publications. And if we look at the internet and we leave out all the HTML pages, we see that PDF is king. So in the latest count, we see that of the non-HTML pages on the internet, 77% or more than 77% are PDF files. And while you see Word files and open document files as some of the alternatives. Now, the fact that PDF is ubiquitous doesn't really mean that PDF is alive. It just means that a lot of PDFs are out there. Suppose that you would create a new document format or promote an existing document format to challenge PDF. What would be the challenges? Well, PDF is you can consume a PDF offline, so that's very important. If you would say, let's make HTML5, for instance, a competitor for PDF, you would need to make sure that all the content is available offline. So if you have some online references or external images, that's something that you'll have to be sure that you can take care of. PDF viewers are ubiquitous, so are browsers, but like EPUB readers maybe not that ubiquitous. You need to make sure that the documents are available for mobile consumption. And maybe you need interactivity. In PDF, you can have forms. You can add comments into PDFs. HTML5 is a good competitor on that, with that account. And for instance, mobile consumption. EPUB is good for e-readers, so you can consume a book offline. But then again, EPUB is a single purpose. It's only meant for books. You could also attack the weaknesses of PDF. PDF suffers of too much functionality. Over the years, people of Adobe and has added a lot of stuff like Flash into PDF, and they are now abandoning it. So PDF, if you saw the spec that was Torrent 2, that was only 1,000 pages. If you would, they no longer print the spec, but if you would look at the standard, the ISO standard, then you already have 1,200 pages, and you need all these technical, extra technical specifications that are written on top of PDF. PDF was also designed in a pre-hacker world, so once in a while we hear about vulnerabilities in PDF, where a PDF is exploited and can do malicious things on your computer, so that's one of the weaknesses. And then one of the bigger problems is that not all tools are created equal. Publishers don't always use best practices, so if you have the choice of 20 producers, most of the producers won't create tagged PDF, whereas tagged PDF, as we will see in our session, is gaining importance. And some PDFs are really, you can open them in Adobe Reader because Adobe Reader is very tolerant towards faults. But then, for instance, if you would open them with ITEX, you would get an exception because the PDF doesn't follow the specs. The same goes for viewers. Not all viewers support all features. So if you have ECMAScript, JavaScript in PDF, so in PDF you can put the same JavaScript as you have in an HTML page, but it won't work on all viewers because not all viewers support JavaScript. Now, PDF is more than just PDF. So it was first released in 1993 by Adobe. But Adobe handed the specification over to the AIIM in 2007 with the purpose to make it an ISO standard. And so the first core PDF ISO standard was ISO 32001, released in 2008. This wasn't the first PDF standard. Before you had some substandards, like PDFX was made specifically for the graphic arts in 2001. PDFA for archiving, we'll focus on PDFA a lot later on, was released in 2005. And then you have all these other standards like PDFE for engineering, VT for variable transactions in printing, UA, we'll focus on UA later on, for accessibility, and then some related standards that aren't released officially yet, but are in the works, XFDF, ECMAScript, PRC for 3D, and PADES is released, and I'll have a short word about PADES later on. Now, I've talked a little bit about PDF. Let's now go to some examples, and I'll switch to Raf, but I have to log in for him. Just a second.
Okay. So,
Bruno, we need to switch.
I have a few slides first.
Okay.
So Bruno gave you a quick introduction on PDF. I will give you a quick introduction to iText to show you how you can use Java code to use our software library to create, manipulate PDF documents. So, of course, we start with a Hello World example, just creating a simple PDF file, which can basically be done in 5 steps in iText. So, first step, you create a document object, which is like an abstract concept of a document. Then we have to make sure that this document can be written to PDF syntax, which is done by a PDF writer. And in this case, it writes to a file output stream, so we'll create a file on disk. You can also write to memory or wherever, but we'll keep it simple and just write to file. We'll have to open the document before we can start doing stuff to it. We add a simple paragraph here. So iText has all these high-level building blocks like paragraphs, tables, lists, list items, but we just do a Hello World paragraph here. And then we close the document. And probably not a big surprise that we now have a PDF document, which is opened here in Adobe Acrobat. which just has one paragraph saying hello world. So that's very basic document creation using iText. Then we move on to manipulating an existing document. So one of the often used use cases is filling out forms, because a lot of companies have to fill out forms and they have the form data ready somewhere. They have it in a database or wherever they have it stored. And it would be silly for someone to type over all the content in a form that they have to fill to submit to a government website or whatever. So we can obviously do this automatically using the iText library. So here's some example code filling out a PDF form. In this case, this is an acro form, one type of interactive form in PDF. So you can see at first we use a PDF reader to take in an existing PDF document. And then we use a stamper to manipulate that existing document. And again, we use a file output stream to write out the new file to disk. We can get the acro fields from this document. And then we just, it's basically key value pairs. I put my name, my own company, and I'm from Belgium. We close the stamper, the reader, and we get the output, which is on the next slide. And you can now see this document is filled. So another simple use case of manipulating an existing PDF document. It's all in a document workflow, or after you have sent out your form to a customer, often there's a final copy of your form. So you don't necessarily want it to be changed afterwards. Maybe you want a final copy of your filled-in form. And in this case, it can be useful to flatten your form, which means you remove all interactivity from the form. Just you remove all the form fields, but keep the content in the regular PDF content. So I have the exact same code here as on the previous code sample. It's Bruno's name now, and at the end there's one line added which says form flattening true, and then the result is it looks exactly the same, but now we have a static, non-dynamic PDF document with the content from the form, but all the interactivity from the form is gone. So this can no longer be changed in the regular interactive form way, which could be useful, for example, to archive this PDF document in your database or your document archival system. You can also see, if you compare to the previous, slide, here you have the purple bar saying this is a form, you can fill it out. On the next one, you can see this is no longer a form. It's just treated as a regular PDF document. Now we'll switch to another use case, adding content to an existing document, but this is a bit more complex. So I'll explain the simple code sample on the slide first, and then we'll go to a live demo. Again, we use a PDF reader to take in an existing document and use a PDF stamper to manipulate that document. But now we want to put a watermark across the document, which just says watermark in this case. So you can see we're using, in the show text aligned line at the end, we're using fixed coordinates to position this watermark. So we have 297 and 421 as the coordinates. And then it's a 45-degree angle to put on the watermark. I'll switch to the demo now. Okay. So I have almost exactly the same code here in my IDE. There's just an added part here to add some transparency so that it looks like a nice watermark. You can see the coordinates for the watermark here, and the angle. This is the text that we will be putting on the document. So if I run this and then switch to the output folder, you can now see we have used the same hello world example from before, and now we have a watermark on this document. So this was for a very simple PDF document. Now, if we switch to something a bit more complex, you will notice that a lot of things can go wrong manipulating existing documents. So in this case, we have a document with multiple pages, and we have the same code stamping on the watermark, and we just loop over every page, trying to get the watermark on each page of the document. So I will run this again. Now you will notice on my first page I don't have any watermark. Also on the second page, no watermark. And if I show you the complete document, which is supposed to be laid out like this, you will see I only have a watermark on page 13. And this is caused by the way that PDF works with a coordinate system. So we have a big coordinate space, and the page is actually just one part, one view on that complete coordinate space. And by convention, a lot of PDFs have the origin, so the 00 coordinate, at the lower left corner of the page. But this is not mandatory, so you can put your page wherever you want in the coordinate space. So this PDF is laid out like this in the coordinate space, because it's meant to be printed separately and then assembled to put the big image together. And because we are using the fixed coordinates in the code, this is actually the content, the watermark content, the text is added to each page, but it's not visible on each page because it's outside the visible area. So we'll try to fix this in our next example. So compared to the previous one, you can see we are now actually getting the page size from each page for looping over it, finding out what the left margin is, the bottom margin, the top, etc. And instead of using the fixed coordinates, we're now using these calculated coordinates to put in the watermark. So again, if I run this, we have the same PDF now, but you can see on each page we now have this watermark. So that's an improvement, but this page doesn't show it for some reason, because it's obscured. You can see it clearly here. It's obscured by the existing content. So again, we take a step back and try to correct this. Pretty much the same code again, but instead of getting the content below the instead of getting a layer below the existing content, we now get a layer on top of the existing content. The rest of the code is exactly the same. So I'll run this again. And finally, we have created the file we wanted to create. We have a watermark on each page, and you can now clearly see it's also on top of the content, looking nicely transparent on top of existing content as we expected it. So this was a basic introduction to creation and manipulation of PDF files. We'll now switch back to Bruno to go into standards.
Okay, so these were some simple ITEX examples. We don't go into much more detail because many of you already know the Hello World example. But the watermark example is one of the frequently asked questions. So there's a lot of people who say, I've added a watermark to my PDFs and it doesn't work. So that's why we added this example. Now, the importance of standards, I'm going to switch to the Bible. And you see the Tower of Babel, where the people of Babel, they wanted to build a tower that reached into the heavens. And because it was really arrogant of them, they got this punishment that they stopped talking the same language. So the carpenter wouldn't understand the mason anymore. And the mason wouldn't understand the guy who brought the bricks over the sea anymore. So not talking the same language is a punishment. And the result is that the tower never got built. Now, why do I show this example? Well, I'm from Europe, and in Europe we have this EID. And the EID is a smart card, and there's a smart card ISO standard. But every single country in Europe has implemented the EID in a different way. So if you write software to read the Belgian smart card, or you write software to read the Portuguese smart card, it's different software. So at the EID and e-passport conference last year, I asked the panel, why is this? Why didn't you follow the standard? Well, the answer was, because not following the standard is a very lucrative business model. And that's, well, we're ITEX, we're open source. We want people to adhere to standards so that there's interoperability, so that we don't need to write the same software over and over again, but slightly different. So not being able to understand each other, especially in Europe, is a punishment, not a business model. And standards are about speaking the same language. I showed you the umbrella of standards very quickly. I'm going to show a couple of real business uses of use cases of the standards. So here we have a simple PDF. It's from a manual to assess people. And everyone can read this. You see a title. You see 3 bullets, step 1, step 2, step 3. But it would be nice if we added some structure. Like if we knew that this worksheet 4, that this is the title. If we knew that there were 3 list items. If we knew that the list items have some list item bullet, like step 1, step 2, step 3, and some actual content. If we would be able to add this content, this semantics to a document, then this document could be consumed by a machine. Because humans can read this document, but the machine doesn't always know that step 1 is part of the bullet. You would have to introduce some artificial intelligence so that the machine knows, hey, we have step, 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 it's repeated, and then 1, 2, 3. This must not be part of the content. So structure would be helpful, but humans can read the document like this. But can everyone read this? For instance, this is an assessment. The purple line is the result you should have. The blue line is the result of a person who did the assessment. But what if you are colorblind? If you're colorblind, you can't see which line is which. Then you see stuff like MGT. Okay, we know that it's the abbreviation for management, but does everyone know this? And also, you have these values, you have these different points in the spider chart, but you don't know their exact value. And so for a human, it can be difficult to read a spider chart like this, but imagine software reading this. How would software interpret a spider chart? You would have to program your software that way that it can interpret, can read all the different lines. And so wouldn't it be nice if we could have a chart like this in our PDF, but add some extra structure to this PDF so that the machine can interpret what this is about. So that a machine, for instance, could extract data where you resolve abbreviations like management instead of MGT, information and business decision support, where you make the info color independent. You see there's a line with the results from a specific person and a line with the results you should have to obtain the position. And then one other difficulty is, what do we put into rows and what do we put into columns? Maybe having 2 records, one for person with 12 properties, one for position with 12 properties. Maybe that's not the best way to represent the data. Maybe this is a better way, so that you can compare. You have 12 records with 3 fields. So if somebody is presented with a chart like this, wouldn't it be nice if we could also add information like this on top of the chart so that a machine can really know what this chart is about? Well, that would be nice, and that's when PDF UA comes to the rescue. So let's agree on a standard way to store and interpret documents. So PDF UA is a standard, a technical specification, where we agree on how are we going to present the data and we are going to mark content so that machines can read the document, but also that the blind and the visually impaired, that they can interpret the document. So if they are colorblind and they don't see the difference between the blue and the purple, you have screen readers, and we'll show an example later on, that can read that stuff out loud so that people who can't see the chart can consume the chart. And so PDF UA provides definitive terms and requirements to allow people with or without disabilities the same rights. This is very important in the US because you have Section 508 here, where it's when a government or when somebody puts a document on a website, it needs to be accessible to anyone, so to people without and with disabilities. And so people equipped with appropriate software, they can, or assistive technology, they can consume the document. So that's why PDF UA is important. A second use case, well, I need some, this is an article from a Belgian newspaper. This guy, Eddie Harens is his name, he was building his house. He was working with a contractor, and the contractor built his house, and he received an invoice from the contractor. So he paid the invoice. What he didn't know was that the invoice was intercepted, and somebody changed the wiring information. So he said, hey, this is from my contractor, I'll pay the bill, but he paid it to the wrong bank account. And the bank, it's in Dutch, sorry, but the bank said he doesn't get his money back because the bank said everything was processed in the right order and we are not responsible. You should have used the correct bank number. So if we receive a document, we want to be sure about the integrity of the document, that nobody changed it underway. Now this is another slide, and we see the Pope Sylvester, and we see the Emperor Constantine, and Constantine is supposed to have handed the deeds to the city of Rome and the Western Empire of Rome to Pope Sylvester. That is supposed to have happened in the 3rd century. And this deed was used in the 8th century by the Pope, who said, I have all the supremacy over Rome and the supremacy over the Western Roman Empire. Now, this deed was used for political reasons, and only in the 13th century it was discovered that this deed was a forgery, that it was made in the 8th century, not in the 4th century, and that it was made to make sure that the Pope had this supremacy. So we had integrity of documents. Second thing we want to achieve is authenticity. If we receive a document from somebody, we want to make sure that this person is actually the person who wrote this document, who made this document. Then we see here Bart Simpson. He has carved his name into fresh concrete. And we all know Bart, when he does something mischievous, he always says, I didn't do it. But here you see the shadow of Marge's hair. So Marge was looking over his shoulder, and he can't say I didn't do it because there was a witness. If we have a document, and for instance a contract wherein somebody promises something, we want to achieve non-repudiation. We want to make sure that the person who gave us the document, who signed the document, can't say, hey, I never saw this document, that's not my document. So that's a third point that we want to achieve. Now, how can we achieve this? Well, let's agree on a standard, vendor-independent way to ensure document integrity, authentication, and non-repudiation. What are we going to do? We are going to add a digital signature that is created with a private key that is owned by the person who is signing. So in Belgium, we all have this EID. I'll just fetch it. So this is my ID card. There's a smart card. That's a smart card. There's a chip on this. And it has a private key owned by me. And so I can sign a document, and a hash of this document will be sent to this little computer on my EID, and this chip will produce a signed hash, so a signed version of that hash, and we can integrate this into a PDF. And then you can see in the left panel that a document was signed by somebody. And if you look at the slide to the right, you see, to the left you see something that was signed by 4 people, by Alice, Bob, Carol, and Dave. And to the right you see the same document that was forged by Chuck. So somewhere in the third part, Chuck has written something that he wasn't supposed to do, to write there. And you see that there are red crosses and yellow triangles appearing, showing that the document has been invalidated. So what is this standard about? Well, you have ISO 32001, which was released in 2008. It was based on PDF 1.7, released in 2006. It gave us some rules on how to create a digital signature. Now, ISO 32002 will define PDF 2.0, but it's only to be expected in 2016. It says 2015, 2016, but actually we know that we shouldn't expect it before 2016. Now, digital signing involves hashing and encryption, and certain hashing algorithms, certain encryption algorithms, well, over the years, people find flaws in it, and computers get more power, so it's easier to hack or to forge documents. And the European Union, they are really eager to use digital signatures. So we see that next to ISO, we have ETSI, the European Technical Standards Institute. They created a technical standard, number 102778, and they created a series of standards, PADES, PDF Advanced Electronic Signatures, and they have introduced some new types with newer hashing algorithms with more limitations on digital signatures, and we see that PADES is now used as an inspiration by ISO to create ISO 2002 and to update the standard on digital signing. So, integrity, authentication, non-repudiation, we have a standard for digital signatures in PDF, and that's a very useful standard. Use case 3, sorry, is a standard called ZUGFeRD. It's a German standard. What is it about? Well, paying invoices can be a pain, but so is processing invoices. If you receive an invoice on paper and you have to put it into your backend, your ERP system, you have to type it over, you have to find what are the invoice lines, where is the sales tax mentioned, and so on. And it's error prone because a typo is easily made, and depending on where you put the comma, it can be a huge difference in what you have to pay or what you actually paid. Now, we need a standard. And what if a vendor would provide an invoice that can be read by a human being? So PDF would be a nice solution. So human beings can read a PDF, but that also can be processed by a machine. So we have a lot of XML-based standards for invoicing, and so that companies exchange XML files. But the problem with XML files is that human beings can read them, but they are not so user-friendly to read. What would it take to make sure that we don't have to do any manual work to input the amount to be paid, to input the sales tax, and so on? So we would need some structured info, an agreement between companies on how will we structure the info. And also important, how will we make sure that the invoice can be preserved for the long time? And that's where PDF-A comes to the rescue. If you have title companies or in Europe notaries, I know our notary in Belgium, he says, I have to build a new garage every 5 years because I have to save all my documents for 75 years. So every 5 years, my garage is full with documents and I have to build another one. What if we could agree on a digital document standard that ensures that a document can still be consumed in 30 years, in 70 years, in 100 years? And that's what PDF-A is about. So let's agree on a standard way to archive documents. And you have PDF-A1, which is based on PDF 1.4. And then came PDF-A2 based on PDF 1.7. And then PDF-A3, PDF ISO 90005 Part 3. It's an identical copy of PDF-A2. Even the typos are copied. There's only one difference. So PDF-A2 allows attachments to the PDF, but these attachments need to be PDF-A2 compliant too, whereas PDF-A3 allows attachments, and the attachments can be anything. So the attachments can be, for instance, an email, can be an XLS file, can be an XML file, so can be machine-readable data. So you have an invoice, which is readable in PDF by humans, and we'll attach an XML file that can be extracted from the PDF by a machine and can be interpreted by the machine. So what the Germans said is, let's agree on a standard way to exchange invoices. So they had the Forum E-Rechnung. E-Rechnung is electronic invoice, Deutschland, and they created this ZUGFeRD standard based on PDF A3, so archiving plus an attachment, but they impose an XML schema for the data added in attachment. So data can be extracted and processed without human intervention. So it speeds up the processing of invoices. It makes the process less error-prone, and it reduces the cost, which is also important. So, conclusions. Why are standards important in business? Well, clarity, as shown in the PDF UA use case. We had this spider chart, and we didn't really know how to interpret it, but if you would turn it into a PDF UA document, then there's an unambiguous way to interpret such a chart. Security. Standards ensure security, as shown in the PADES use case. No more invoices that are forged, no more sources that are unknown, and no more people who can say, hey, I didn't sign this document. And interoperability, as shown in the ZUGFeRD use case. If everybody started using invoices like that, you could exchange invoices and really improve the processing of invoicing. And there's much more to standards, but now I'm going to hand over again to Raf, who is going to talk some more Java and who is going to show you the technical aspects of PDF UA, PDF A, tag PDF, and so on. So how does that work? How does what I explained work?
Okay, so Bruno gave you the introduction to several standards in PDF. I will now handle the practical stuff, how to create such PDFs that conform to these standards from Java point of view using iText. I won't go into all the details of all these standards. Instead, I will highlight some important points and show them in a very practical way how you can achieve having these requirements or restrictions in your PDF document to have something that conforms to the standards. So it's important, as Bruno showed at the beginning of the presentation, that we have the PDF standard as an umbrella standard, and whatever is added on top, like UA or PDF A, is actually just PDF technology and is a certain way of using that PDF technology. So they're not new technologies, they're just like a set of requirements and restrictions how to use the existing standards. So let's keep it simple at first. Step one, just create a simple PDF, like we did in the beginning with the Hello World example. So again, we just open a document. We create a document object. We use a PDF writer again, and you can see we use a file output stream again to create a file called simplepdf.pdf. We're creating PDF version 1.7 here, and we open the document so we can start adding content to it. We're adding a bit more content as in the Hello World use case in this example. So you can see all the lines marked in blue and in italics are building up a paragraph, and the parts in red, in bold, are adding content to that paragraph. So we have a chunk, which is basically just a piece of text at first, which says the quick brown. And then we have an image of a fox. Then we have a part of text again, which says jumps over the lazy. And then we have an image of a dog. We add all these chunks and images to the paragraph, and then finally at the end, at the last line, we add this paragraph to the document. Then we still have to close the document so that everything is flushed to disk because of the PDF writer writing it to file. And we have a PDF document, a very simple PDF document that has the content as we added it to the document in this example. So this is probably not a very unexpected result for anyone. But we'll use this example to go through the different standards in the rest of these examples. So let's take this PDF and add tagging to it, because if you look at the previous PDF, there are some problems with it, as Bruno explained. If you want to consume this PDF in an automated way, like by a machine, all kinds of problems can arise. The PDF is pretty simple, but still the images are problematic, because if you want to consume this by a screen reader, imagine you are a blind user and you have your assistive technology reading this document for you, it will not be able to spell out or read the image of the fox and the dog for you. Also, if you want to store this document and make it searchable, it will be difficult to search for a document that has an image of a fox, because your search capabilities will not allow this. And although this is still a pretty simple example, but consider a table, for example, in a PDF document. In a very simple way, if you added a table in a very simple way to a PDF document, it would basically be a bunch of lines making a rectangular structure, and then adding the text content at strategic positions between those lines, so it looks like a table. But your machine processing this, or your software processing this, has no idea that this is a tabular structure. So to resolve these issues, we will be tagging the content so that the semantics and the structures are added to the PDF document, so that on top of the visual representation, you also have structural information in the PDF. So if we compare with the first simple PDF creation example, we just have to add one line using iText, which says to the PDF writer, set tagged, so that it will create tagged PDF. And it's this simple using iText, because we have these high-level building blocks like the paragraphs, the tables. So actually we have all this information ready, but when creating a very simple PDF, it's all thrown away, and we only keep the visual representation. Once you tell the PDF writer to use the tagging, it will be able to build a structure information, add all the extra information that we need in place for automatic processing and assistive technology. So if you look at the output of this tagged PDF, this is a screenshot of Adobe Acrobat. You can see like a structure tree on the left. So at first we see the P tag, which is the paragraph. We have a span, so a piece of text, quick brown fox, then an image, then another span, another piece of text which jumps over the lazy, and then the image of the dog again. So of course you can see, compared to the first one, this is a lot easier for software and any automated way to process this document. Another important feature of this is that we now have a logical content order, because PDF can work with absolute coordinates. You can position anything anywhere, like we saw in the watermark example. But if you want to have your document read out loud by your software, it will need to know in which order to read this content. So now we also, apart from the structure information, we also have the content order in place to process this document. So tagging is already a big improvement over the simple PDF case, but let's take it a step further and go to actual universal accessibility, so PDF UA, building on top of the tagged PDF case. So first thing we have to add is a lot of metadata. So metadata is descriptive information about the document, not the content itself. And one of the requirements is that we have to add all kinds of information about the title, the author. We have to add keywords, which helps with indexing and search capabilities, for example. We also have to specify in which language the document is written. You can imagine if software has to read out loud a document, it's very helpful that it knows in which language the document is written, so that you don't have an English voice trying to read a German document, for example. So that's very helpful. And also we have to specify that the document conforms to PDF UA, which is helpful for whatever software opens the document, so that it can act accordingly to this type of document. So, building on top of the tagged PDF example, one of the requirements is that we have to show the document title at the top of the window when you open it in your viewer, in your PDF viewer, for example, which is done by setting the viewer preference in the first red line in bold. We're adding the language of this document, which is US English. We say this document is an English pangram, so a pangram is a sentence containing every letter of the alphabet. This is the title of this document. And finally, we tell the iText PDF writer, store all this metadata in XMP, which is a standard well, it's a structured way to store metadata. And this will all be added to the PDF document. A few screenshots showing the result, the output result of all this code. So you can see on the left, the title is now stored in the document. If you open up the document properties, you can see now the title says English pangram. On top, you can also see the title is displayed in the window as required, and in the metadata, you will see that there's an entry added to identify this document as PDF UA, which is helpful for whatever software tries to open this document and process it in an automated way, because it will know what to expect of this document. Next requirement is about fonts. So for a PDF file, it's perfectly valid to just specify fonts by their name. So you can say in a PDF file in the syntax, display this part of text, this piece of text in Arial or Times New Roman or whatever, and then it's up to the PDF viewer to figure out where that font is and use that font to display the text. But of course, it's not guaranteed that this font will be available on the machine that you will be opening the PDF on. So in that case, the PDF viewer will have to use a font selection strategy to find a suitable replacement for that font, and it will try, based on the information it has, try to find something that is very similar. But of course, there's no guarantee at all that there's a similar font available on the machine. So that's why, in this case, for accessibility, we need font embedding, so that the document is completely self-contained in terms of fonts. Just putting the font in the file, so that there is a guarantee that you can use the exact same font for viewing as there was used for creation. So this makes the document fully portable in terms of fonts, because all the font information is in the file itself. So when we added the paragraph before, we didn't specify any font information at all, which means that iText will use Helvetica size 12 by default. Now we're specifically setting a font. We're using a free font file, TrueType font file. And in red you can see in bold that we are now telling iText to embed the font in the PDF. So before and after screenshots showing the document properties. On the left you can see we specified Helvetica, but it also shows that the actual font used was Arial MT. So it didn't use the exact same font as I used for creation of the file. Of course, these are similar or even completely the same, so it doesn't show up visually, but conceptually the same font was not used. On the right you can see we now have the Free Sans font, and it is embedded. It's the subset, the part of the font that was actually used, the characters that were used for this file are embedded into the PDF file. So as I said, it's not visually apparent in this file that a different font was used to display it, but here's a more, let's say, extreme example. So on the left a screenshot of a PDF that was created using a Walt Disney font. And on the right, you can see how the PDF is displayed on a machine that does not have this font. So if you spend a lot of time creating a nice looking document, it's a pity that you will have your users seeing the document as the one on the right. So that's why font embedding is very important. So that you can prevent bad font substitution by the PDF viewer. Then about images and alternative text, as I said before, the quick brown fox jumps over the lazy dog example. The images are difficult to consume by software, so we have to provide suitable alternate text for non-textual content. And this is helpful for the read out loud functionality of assistive technology. So when we added the fox image, we can simply say there's an alt text saying fox. If you look at the figure, the image of the fox, and you open up the properties, you can now see that it says alternate text fox. I will try to demonstrate this using the read out loud functionality. So we have this read out loud. Sorry. So we have a read out loud functionality in Adobe Acrobat. So I'll activate it and read out loud this page. Okay.
It's too quiet.
It's
once more.
Speakers.
The quick brown jumps over the lazy.
Well, let me just tell you what it says. So Adobe Acrobat tries to read this file, and it just says the quick brown jumps over the lazy. Imagine you're a blind user. This is not very useful, of course. If we take a look at the accessible file, as I showed you, we now have the tagging, and for the figure information of the fox, it has the fox alt text. For the figure information of the dog, we have dog. So now if I would be able to let you hear the read out loud functionality, it will actually say the quick brown fox jumps over the lazy dog, which is of course a lot more useful if you are a blind or a visually impaired user. All right, this is a screenshot of the pack tool, the PDF accessibility checker by XY Media. So we've run our result of the previous code samples through this checker, and it says this PDF is technically accessible. So we've covered all the technical requirements, but of course this is still not a guarantee that it's really a completely accessible PDF, because a lot of requirements cannot be checked automatically. A simple example, we cannot check automatically if the author chooses to enter very bad alternate text for images. If he would switch the fox and the dog alt text, of course it would be completely wrong, and there's no way to check this automatically. But still, this is a way to at least check that the technical requirements are met for the document. Okay, now let's take a step back and start from regular PDF again and try to create a document that is suited for archival. So PDF A, we commonly say A for archiving, it's actually PDF for long-time preservation, as it's called in the standard. So again, it's a set of restrictions and requirements on top of PDF to make sure that your document is suited to be stored for a long time. Like the example that Bruno gave about the notaries having to store their documents for 75 years or something. And if you summarize the specification, it mostly says that the document has to be self-contained. So it cannot have any links to outside resources. Everything has to be in the document so that if you retrieve it in the far future, you have everything ready to view or consume or do whatever you want with your PDF document. First, we'll have a look at PDF A3B. B is commonly referred to as the basic level, which is only concerned with visual representation. So it's only the visual stuff that's important here. So the basic part of a PDF creation is very similar. Instead of a regular PDF writer, we now use a PDF A writer, which is a separate implementation in iText, taking care of all the PDF A stuff. And we can specify the conformance level of PDF A that we want. So in this case, we specify PDF A 3B. Again, we have to add metadata. This is very similar as in the PDF UA use case. We also have to specify which type of PDF this is so that it can help the PDF reader. You can see after adding the PDF A metadata, if you open the document in a Reader or in Acrobat, it now has this blue bar saying the file should be PDF A compliant. And it also tries to prevent accidental modification of this file because it's a file intended for archiving, which probably should not be modified after it's been archived. You can see in the document properties it says it's level 3B now.
Well, one extra comment. So the blue bar is shown when you set these values, but having the blue bar doesn't always mean that the PDF is actually PDF A. So you should verify for, so the blue bar shows up when you set the flag, but you should verify if it's actually PDF A.
Yeah. Yeah, the blue bar just says this file tries to identify itself as PDF A3 or PDF A in general, but there's no guarantee that it actually complies to the standard. So there's separate checks needed. Because
some of our users, they just set the flag and then they said, hey, it doesn't work, but you have to do all the stuff that is needed. And that Raf is going to explain.
Okay, so again, font embedding is basically the same as the PDF UA use case. You need to have all your fonts available so that you don't have to rely on the font selection strategy of the viewer or the software. And then we have a requirement on output intents, which is related to color information. So if you use colors that are device dependent, and in the future, in 20 years, you have a different device, there's no guarantee that your colors will display the same as they do now on your screen or whatever you are using, to display your document. So we have to find a way to make colors device independent. And we can use an ICC profile, which is basically a mapping of colors to make these device-independent colors. So we can read out an ICC profile from disk, from file, and then use the PDF writer to set this as an output intent using the ICC profile. In this case, it's an RGB-based ICC profile. If you look at a PDF on a low level, just using it opening it in a text editor, for example, you can now see it has output intent information using this ICC color information. And if you put all this together, run all the code, and look at the end result, doing the PDF A3B compliance check in pre-flight in Acrobat, you can now see Acrobat confirms that there are no technical problems with this file, and it's PDF A3B compliant as far as Acrobat is concerned. So we've seen the accessibility part, the archiving part. If we put all this together, we can go towards PDF A3A, and the A is referred to as accessible. So this is a PDF file that is suited for archival, but it also has all the accessibility requirements in place. So we just take a PDF A3B file, add all the accessibility requirements. So basically, we just have to tell our PDF A writer we now want conformance level PDF A3A. And it will update the metadata as expected. Again, a pre-flight check, doing the conformance check in Acrobat shows that we now have a file that complies to PDF A3A, so we can archive this file, have the guarantee that it will still be usable in the far future, but also have this ready for use by visually impaired users, blind users, or by software in general. So, as Bruno mentioned about the blue bar showing up in Reader or Acrobat, that's not a guarantee that your document is actually PDFA compliant. So, an important question: can I make sure that I am compliant when creating documents? Using iText, we will perform a lot of checks from technical point of view, throwing an exception when you're asking for conformance level 3A, for example, and you're doing something that is illegal, or you're forgetting something that is required, then we'll throw an exception preventing you from creating a document that does not conform to the standard. But of course, as mentioned before, we cannot check everything automatically. Like the bad alternate text for images, we cannot make sure that you actually do it right.
You don't want a text saying the quick brown figure 1 jumps over the lazy figure 2. But
so here's an output example. I tried to create a PDF A3 file using Helvetica, but I didn't embed the font. So iText will throw an exception telling me all fonts should be embedded for the conformance level that you're trying to get, and this one isn't, Helvetica isn't, so that I can fix the problem before I, for example, set up a batch processing, putting all my PDF files in the archive, and finding out in 15 years that all my files are invalid. Okay, so a use case on top of PDFA is the German ZUGFeRD standard. It's not that important that it's German, it's just the general concepts that are important. So we will try to add an attachment, an associated file embedded in the PDF, which has the structural invoice information, and then have a visual representation of that invoice in PDF. So we start from PDF A3B again. In iText we have added a separate conformance level for ZUGFeRD, which is very similar to the PDF A3 conformance level. We have to add some separate metadata, XMP metadata, specifying which embedded file is the actual invoice. So you can see the line in bold. It just has the ZUGFeRD document file name specified as invoice.xml in this case. And of course, we still have to attach the actual invoice information in XML, which we can do by telling the PDF writer to add a file attachment. We specify a description where the file is on disk, and it will add it to the PDF. And also, a requirement is that the AF relationship value is it tells how the associated file relates to this PDF. And in this case, we tell the document that it's an alternative representation. So you have the visual representation, and as an alternative, you have the structured XML representation. The end result then is we again have the blue bar saying this is a PDFA, or this should be a PDFA file. And in the attachment pane, you can see we have an invoice.xml attachment, which is described as ZUGFeRD invoice. You can click this, double-click this invoice, open it in an XML viewer, or your software can extract this information automatically and process it in any way that your invoicing needs to be processed.
Okay, back to PDF, and I'll switch places in a moment and show you what the results are, what the PDFs look like from the inside. So we'll look at the structure of a PDF file, and we'll look at the PDF from a text editor, but we'll also browse. PDF is actually like an object-oriented language. We'll browse a PDF using Java Swing. Very basic. A PDF usually, well, there can be more parts, but let's, for the sake of simplicity, say that a PDF consists of 4 parts. You have a header part, a body part, a cross-reference table, and a trailer. And to illustrate this, I'm going to switch places with Raf, and I'm going to look at some PDFs. Switch. Yeah. So, oh, that's louder than I expected. We have here a Hello World PDF, and we can open this in Notepad++, and we see what we look at what the PDF looks like on the inside. Here we have the header, %PDF 1.4. Here you see the version number. This can be another version that's just indicative 1.4. The version can be stored elsewhere too, so you don't always have to trust this number. That's legacy. And then we have some gibberish. Why is this? Because PDF is a binary format, and if you transfer a file, sometimes in the past, a binary file used to be processed as a plain ASCII file, as plain text, and then the file would be corrupted. So to tell transfer protocols, this is a binary file, we add some characters that have a value higher than 127. Then we have the body with objects, and we see that the objects, we start with object 2, and here is object 1, and then 3, 4, so objects don't need to be stored in their logical order. How does a computer or a PDF consumer find these objects? Well, you'll start reading a PDF from the trailer, and you'll say, hey, where does my X reference, my cross-reference table start? And this is a byte position, 608, which points at xref. We see there are 7 elements, 0 to 6. Object 0 is a free element. But then we see object 1 starts at byte position 258. Object 2 starts at byte position 15, and so on. And although this file, if you open it in a viewer, says hello world, we don't see hello world anywhere. Actually, hello world is stored in this compressed stream. Now, when I first started writing iText, I needed to debug PDF files like this. That's not very easy. So we wrote something called RUPS. I'll open it, inspect PDF. RUPS is reading and updating PDF syntax, and it gives us a tree view of a PDF. So we have the xref file with all the objects. So object 1, object 2, object 3, object 4 to 6. And we have a tree view that we can open, and we can see this is the root dictionary. And the root dictionary is of type catalog. And it has a page tree. And this pages element has one kid, and this kid is object 4. And object 4 represents page 1. And we can look at the contents, and the content stream is a stream where it says hello world. So there are some positioning positioning operators, and then actually the text. Now, if you see this, you say, hey, this is really simple. We see hello world there. That's nice. But I have here 3 files. So the first hello world, a second hello world, and a third hello world. To the naked eye, for a human, these look like 3 identical files. But as Raf explained, you shouldn't expect that this content is always stored the same way. So if we inspect the hello snippets example, and we look at the contents, we see that now hello world is stored all in different letters. So we have 1 show text per character. Hello world. So this looks identical to the previous file, but the content is stored in a slightly different way. And what Raf thought about the logical reading order, so in PDF UA, you have to make sure that the reading order is correct, the way a human would read it. Here we have the same hello world, but where if we look at the contents, just a second here, we see that actually it says hello world low. And these different text snippets are positioned using their coordinates. So for many different reasons, PDF producers can choose to position text in an order that isn't the logical reading order. For instance, you could say, first I'm going to put all the letter A's on the page, then all the letter B's, all the letter C's. So you don't need to have the logical reading order to have a perfect PDF. But of course, if we think about accessibility, if we think about processing a PDF with a machine, not by humans, but by a machine, we kind of like the fact that the logical reading order is respected. Now, a challenge to make a PDF file is how are we going to present data? So as everything is positioned at an absolute position, and we want to show a line, so 0 hello world, 1 hello world, 2 hello world. When we create a PDF producer, we have to know where the boundaries of the page are. Here it says 7 hello world, 8 hello world, and so on. If we look inside, we say inspect PDF. We look at this page, at the contents. We see that there's much more text. It says hello world 7, hello world 8, hello world 9, hello world A, hello world B, and so on. This PDF producer, well, we made this deliberately, of course. This PDF producer added content outside the visual area of the document. That was also what happened with the watermark example, where we added a watermark at absolute positions, and the watermark text was added to the file, but we just couldn't see it because it wasn't at the right coordinates. So a challenge of a PDF producer is how do we, if we create a paragraph and we add it to a document, how do we distribute this paragraph over different lines? So here we see a hello world, we see something with the same content, but now it's distributed over different lines. So if you look inside, inspect PDF, and we go to page and contents, we have the stream, and we see that the content is distributed over different lines. Now there's something special about these two texts. If I open it in Notepad++, I see this in clear text. Here we said don't compress the content. Now, it's very tempting for people, if they want to change something in a PDF file, it's very tempting to say, hey, I can see this text here in clear text. Let's replace it, and let's say instead of hello world, let's say I'm from Belgium, so goeiedag wereld. So I'm translating it. I replace everything. Don't do this at home. So I've changed the content. I'll save it, and now when I open the file, I will see. Okay. Everything, I mean, my goeiedag wereld, it takes more space than hello world, and I go out of the boundaries, out of the visual area of the PDF. One other thing, when I close this file, it says, do you want to save changes to 04 hello reflow PDF before closing? Why is this? Well, I did something that was kind of illegal, in the sense that by adding more bytes without changing the cross-reference table, I corrupted the PDF. And Adobe Reader is very tolerant about this, because Adobe Reader will say, hey, I'm looking for an object, but I don't find it at the right position. So Adobe Reader will fall back on what's here, 2.0 object, 4.0 object. Adobe Reader will look at these objects. Not every PDF viewer will do this. Not every PDF consumer will do this. ITEX has this fallback also, and will set a flag, this PDF has been rebuilt because the offsets of the bytes were wrong. But for instance, a PDF that is wrong this way can't be digitally signed, because to digitally sign a document, you need to have a document that is 100% okay. And so that's something to watch out for. Okay. We have the FoxDoc example without tags. So Raf has already tried to have it read out loud. Okay, that's not what I wanted to show, but let's look inside. Inspect PDF. If I look at, let's say, the structure, there's no structure tree in this example. If I look at the page, I will see that the content stream starts with the images. So iText, if you don't say set this PDF as tagged, will try to organize the content in such a way that the images are written first so that they don't cover any text. If you want images to cover text, you have to tell iText to maintain the order in which you add content. And so the images, we have some positioning information, and then go to a resource. Images are external objects. You store them once in object. Here, image 1 is stored in object 3. Image 2 is stored in object 0. And if we look at the streams, we see that we have the dog in object 3, and we have the fox in object 2. And going back to the structure, we see the quick brown jumps over the lazy and the 2 images. Now, this is a PDF that isn't tagged. Let's now look inside the PDF with the tags. Immediately when we go to structure, we see the same structure we saw before in Adobe Acrobat. And we see that there's a sequence, 0, 1, 2, 3. And if we go to the page now, so we go inside and we go to the contents, the stream. Yeah, we now see, let me enlarge this. We now see that there's marked content. So the quick brown has marked content ID 0. Then you have this image with marked content ID 1. You have jumps over the lazy with marked content ID 3. And finally, you have the image of the, oh, sorry, it was 2, and you have the image number 3. And so if you look inside the content stream, you have all these IDs, and these refer to the structured tree root. So the catalog in such a PDF has much more information, many more keys than an ordinary PDF. You have the metadata. So this is the XMP, Extensible Metadata Platform version of the metadata. Actually, this metadata, if I open the document in Adobe in text editor, I can see the metadata in plain text normally. That's towards the end. So here you can see the metadata, the XML in plain text. Why is this? This is so that software that doesn't understand PDF can look for a specific sequence, here, this sequence, and can extract information about the PDF without having to read the actual PDF. This XMP metadata, you can also find such metadata in JPEGs, in image files, in any kind of document. So XMP is like a standard for metadata that can be used in many different document formats. But I was talking about the structured tree root, where we will find the document and the complete structure tree with the spans and the alternative text. So here you see dog for the image. So creating a PDF that can be consumed by a machine or can be read out loud correctly involves a lot more infrastructure inside your PDF. And then finally, the ZUGFeRD invoice. Let's inspect the PDF. Now we have associated files. And in these associated files, we have a relationship, an alternative version of the actual invoice. So this is the invoice for human consumption. it's just a phony invoice. But here I have a file stream, and this file stream will give me the same information but in XML format. Now you can see there's some strange signs here, but if we save to a file and we say, let's save this on the desktop, where is my desktop here, and let's say invoice XML, no, it's a comma, invoice XML, save. Here I have my invoice XML. Let's open it in Notepad++. Oh, I only saved. Yeah, I selected. I shouldn't have selected the euro sign. Save to file. Desktop. Invoice XML. Save. Now I should have the complete file. Okay, this is my invoice in XML, and so a machine can easily extract this stream and process it. Is there something else I should tell here? And well, we see the output intents. That was what Raf already explained. Maybe one more difference. Embedded files. So embedded fonts, sorry. So if I look here inside this document, I have page resources. And my font dictionary is just Helvetica font type 1 with ANSI encoding. There's no description of what the font looks like, and this is with an embedded. Yeah, this is with an embedded. So if I inspect this PDF, I have this page, I have the resources, I have a font resource, and now I have a font descriptor. And in this font descriptor, I have a font file, and this is actually a compressed font file where. And if you know PDF, you see that we have 3 sans, and if it's preceded by a 6-letter code plus and then the name, you know that it's a subset of the font. So here you have the description of how do I draw all the glyphs for every character that I have used in my quick brown fox example. So to sum up, to summarize. PDFs can be quite complex, but we have this tool called ITEX RUBS to look inside PDFs and to debug PDFs when necessary. Okay, I'll hand over to you.
Okay, so we've seen that in a lot of cases it's a lot better to have this structured information in PDF. But now an important question is there are a lot of PDF documents already in the wild which don't have this information. Is it somehow possible to process these unstructured documents, determining the structure of them, and maybe add that structure so that we have a new PDF file that is better in terms of accessibility and indexing and all that stuff. So first, the basics. Here's some Java ITEX code to get the text information out of a PDF file. It's a listener implementation. So when ITEX processes the content stream, as Bruno showed in RUBS, it will do callbacks to such a listener. And in this case, whenever a text block begins, we write this smaller than sign. When a text block ends, we write a greater than sign. We just skip images, so the render image method is not implemented. And for texts, we have this text render info, which contains all the positioning information, font information about a piece of text. So we will just write out the coordinates, the length of the texts, so not length in terms of characters, but length in terms of pixels or user points, and then the text itself. Here's a piece of code to actually read out the text or the complete content stream of a PDF document. So again, we use a PDF reader to take in an existing document. Then we have the render listener, the my text render listener, which was shown here. We have a PDF content stream processor which can actually read this content stream. We go to page 1, as you can see at the end of the code sample. So we get the content bytes for page 1 from this existing reader. Let me show you what this does. So I have this same code sample here, and I'm doing this for the Hello World examples that were shown before. So I will run this code sample. And it has written out the text content, well, the content as processed by the text render listener to text files. So I'll show this one first. You can see it's pretty straightforward, as was shown by Bruno in RUPS in the first file. We just have the coordinates, x at 36, y coordinates here. This is the length of this part of this piece of text, and the actual text says Hello World. So very straightforward. We can extract this information. Now, for the second example, you can see this was the example where all the letters were added separately to the Hello World PDF file. So you can also see when we extract this, we have separate coordinates for each letter. And we also have the H here, the E, the L, which spells out Hello World. But it's stored very differently, and obviously it will also be extracted very differently if we process this file. And then the one where the content wasn't in logical order, again, we have different coordinates for the different pieces of text. We first have hell, then we have world, and then we have the low part of hello. And by inspecting the horizontal coordinates, you can see that this at 53 should be placed in between 36 and 66. So the low part comes between hell and world. So obviously this shows how difficult it can be to actually get useful text content out of a PDF document. We have an implementation in iText that takes in all this coordinate information and tries to puzzle together all these pieces of text to get actual useful text content out of the content stream. So there's this convenience method, getting the text from a page using the PDF text extractor from page 1 again. And I will run this again for the 3 files that I showed before. Now it will display to standard out. So you can now see at the bottom of the screen we're extracting Hello World 3 times, because now we have processed all this coordinate information and have puzzled everything together so we can actually have useful output. Now, let's try to do this for a page, a PDF page that is a bit more complex. So we've taken a page from the iText in Action 2nd edition book. You can see there's a few paragraphs, there's a header, there's a caption at the bottom below the image, and there's the image itself. At the top right you also see a page number and the title. And of course, visually as humans, we subconsciously infer all this structure information. We recognize paragraphs, we recognize section headers and all that. But for this file, this structure is in no way stored in this PDF file, in this document. So let's try to detect this information using iText. So using the same text extraction and image extraction implementation as before, we are processing this page. But instead of writing out the text to standard out or to a file, we are now highlighting it. So we have this highlight method which actually marks the different parts that we have detected in the PDF itself. So we can have a visual inspection which is useful for demo purposes of the different parts that we detected. So we're just drawing rectangles based on the coordinate information that we get from the content stream on the PDF file itself. It will become a lot more clearer when I run this file and show you the output. So this same page is now marked with all rectangles that we have drawn based on the coordinate information from the text. So you can see basically all letters are marked in blue because they are all parts of text in the content stream are marked in blue because they're detected as text. The image at the bottom is marked in red because it was identified as an image. You can also see some words or several words are stored as one piece of text, like which questions A. But there are also words which have their letters stored separately. So for some reason, the PDF producer that created this file decided to store it in this way. For example, here we have was. The W and the A are stored as a piece of text, and the S is stored separately as a piece of text. But all the coordinate information makes sure that visually this looks as expected. Of course, having this information is not yet very useful to have structured information in any way. And of course, when creating this file, when it was created, all the structural information was thrown away. So it is difficult to get it back again. So we'll have to add some, let's say, human input to be able to get structured information out of this. So let's say that we configure this extraction to say the top margin of 48 points is reserved for artifacts like title information, page numbering, which is not actually part of the content. We could identify regular text by font. So the new Baskerville font and Courier font with font sizes 10 and 9.5 are used for regular paragraph content. And section headers are written in Franklin Gothic font, 10.5 points. And captions have the same font in font size 8. So this is specifically for this file, of course, but it's a way to make a distinction between the different parts of this content. So if we add all this input, this human input, to the algorithm and run it again, so it basically does the same thing as the previous one, but now it has extra information that we added. We now get a highlighted file again, and you can see the artifacts at the top are now marked in gray because we configured artifacts to be marked gray. Paragraphs are basically still the same, marked in blue. You can see that a section header is now in orange or some kind of yellow, and figure caption is now marked in green. So we've already been able to make the distinction between the different types of content in this on this page. Of course, we still have some work to do. So now let's try to piece together all the different parts of text so that we can have actually text lines. So doing the same thing again with some extra logic in the algorithm. So you can now see, instead of having all these different pieces of text which are arbitrarily stored in the PDF, we have now detected actually text lines And we can do this because we have coordinate information, so we can also determine the baseline of each piece of text. So things with the same baseline will be on the same line and will make up one line of text. Then going one step further, we will actually try to find structure information. So adding a bit more logic to the algorithm. We can now also piece together lines of text so that we can actually determine paragraphs. And so if you now have an overview of this page, we've been able to detect all the structure information that a human immediately sees when taking a glance at this page. But of course, not having the information in the file makes it very difficult for an algorithm, for software, to do this kind of detection. So this is like a proof of concept implementation to do this kind of structure information. There's still a big step needed to be able to use this information to go to tag PDF or PDF UA output. Okay, then it's back to Bruno.
So one of the frequently asked questions is, I have a PDF and I want to highlight this or that word. The proof of concept here showed that it's not always that simple to implement this. Now, the proof of concept was based on a project we did for a service provider in the pharmaceutical sector, where they have all these files that need to be shipped to the FDA, and sometimes the file doesn't have a table of contents, and by detecting titles based on font sizes, font types, font colors, we can create a table of contents and then link to the exact pages of where these titles can be found. Now, wrapping up, I'm going to go a little bit back in history and talk a little bit about the roadmap for INTEC. So every year we kind of define what are we going to do regarding new developments in this year. In 2012, we looked at mobile versus cloud. So ITEX is a Java library. We have a C# port for ITEX. So the step to make an Android version was very small. We have some demos at our booth of ITEX running on Android. But once we had an Android version, it was also very easy to create a Google App Engine version, because there's not that much difference. There are only a couple of rules that you have to follow about the file system. Digital signatures, I showed you the specs that ISO 32001 dates from 2008, and there were new hashing algorithms, new encryption algorithms. So in 2012, I wrote a 150-page white paper about digital signatures. It needs to be updated because there are some new evolutions, but that's something that is for next year. So we provided a lot of documentation about digital signatures. We saw that digital signatures are really hot in Europe, and we see that in the States that with the common access card that digital signatures are finding their way into business too. XML worker and XFA worker. Raf showed a very short example about filling out a form, and it was an acroform form. You also have XFA forms. XFA stands for the XML forms architecture, where the PDF acts as a container for XML. And the forms based on the XFA technology, they are really dynamic. Acroforms, every field has its specified coordinates. They are fixed. You can't change the coordinates, or if you change the coordinates, you get a bad result. XFA, XML inside PDF gives you a lot of more freedom regarding number of pages and so on. But in 2012, the XFA spec is really huge. We started with something called XML worker, and we tested with HTML, so XHTML to PDF, as a first step towards implementation of XFA to flattened PDF. Why flattened PDF? Because XFA isn't compliant with PDFA, isn't compliant with PDF UA, but XFA has structure. So if we could create PDFA or PDF UA from an XFA file, we would have a really nice product. 2013, we started working on creating tagged PDFs from high-level objects. That's what Raf has shown. So where you say, I'm using paragraphs, tables, and so on, and I'm going to tell the PDF writer, set tagged, so I want tag PDF. Then the information, the semantic information, I am a paragraph, I am an image, and my alternative text is not figure 1, but is fox or dog. That's what we started implementing in 2013. And we focused on standards. So we had some PDF A1 functionality, but we prepared iText for PDF A2 and PDF A3. And we introduced a first implementation of PDF UA. PADES 5, it was not that good a choice of us to implement this, because you have these standards, PADES 5, and the standards for PADES 5, that's signing of XML of these XFA forms. And the standard as developed by ECMAScript was not the same as the XFA specification. So there were contradictions between the XFA specification and the standard. And we implemented PADES 5, but nobody ever used it. So we asked Adobe, what is your view on PADES 5? And they said, we're not investing in it anymore because there's no market for it. So that was an investment that we did, but for now, maybe it needs some more time, but that's fine. For 2014, we did a major upgrade for RUPS. So RUPS was meant to be reading and updating PDF syntax, but before 2014, all you could do was reading PDF syntax, so what we've done, what I've shown, looking at the PDF. But now we can also tweak PDFs. If we want to debug a PDF, it's handy if you can change some value in a dictionary into the PDF without breaking the cross-reference table. So you saw that I manually changed a PDF and then I broke the PDF, broke the cross-reference table. With RUPS you can do minor changes, and don't do that if you're not a PDF specialist, but you can seriously break a PDF like that. But it's handy when you're debugging a PDF. And in 2014, we had more and more customers for XFA Worker. So XFA Worker is now an enterprise-grade solution. And we have customers using XFA Worker to have a workflow where you have this an XML-driven workflow where you inject XML into a PDF to show the PDF for human consumption. And then when you want to persist a form, we flatten the PDF into a PDF A or PDF UA or PDF A plus UA, and then we can digitally sign the document. So, and we don't sign using PADES 5, but we sign using PADES 2 or PADES 3. And in 2014, we also completed the work on PDF UA, PDF A2, PDF A3, and ZUGFeRD. One comment I still have to make about the slides for ZUGFeRD. These examples are for testing purposes. They were made before ZUGFeRD was officially released. And for instance, the name of the XML file, we called the XML file Invoice XML, but no, there are really you need to name your file Invoice ZUGFeRD Invoice XML. So sometimes we are ahead of the specs. For 2015, what we built after the experience with PADES 5, we like to tune our roadmap based on what customers need. So one of the things that is now asked by many different customers is redaction. What is redaction? Well, you saw that words in a PDF, they aren't really words. They can be snippets of more than the word or only the different characters. And there was a scandal a while ago where AT&T was giving PDFs to NSA, and they wanted to obfuscate names of their customers. So what they did was they put black rectangles on the PDFs to obfuscate the name. But of course, these black rectangles, they hide the text when you look in a viewer, but you can still copy-paste the text underneath. The text underneath isn't gone. So one of the things that will follow out of our research and development project that Raf showed with detecting where are which words will be actual redaction, where you have a rectangle and we are actually going to remove the content that is under this rectangle, because we can extract all the positions of every character. We are actually going to remove them from the content stream. Unstructured PDF, so we are in 2015 we hope that we can turn our research into actual development. We see a lot of difficulties, like there will always be manual or human inputs to really find what the structure is like the division in different paragraphs. That will work if the last line in a paragraph doesn't end at the same position as the previous line. So iText will look at different lines and will look where does a line start and end. And if it sees like an indentation, it will say, hey, I have a new paragraph. But that's not foolproof. So we are going to find a generic way to deal with unstructured PDFs, and then try to, well, we don't know if we'll succeed in 2015, but try to be able to, if we have predictable PDFs, if we know we have a set of PDFs that has been created with the same software, we can predict the structure, then we hope that we can turn PDFs that aren't PDF A level A into PDF A level A, but that won't always work without human intervention. And then PDF 2.0, we've already implemented some features that will be new in PDF 2.0. And the next ISO committee meeting in November 2014, so it's always in flux. Some things that were in the draft before are now under discussion. So it's kind of a procession where we go 2 steps forward and 1 step back. But it's something that we are actually actively following up. Now, many people know that I've written 2 books. The first book, iText in Action, it got a real boost when James Gosling blogged about it. So I didn't know that James was going to write a blog about iText in Action, and suddenly I saw the sales numbers go through the roof, and I said, what's happened? And James actually used my affiliate link. So for every book sold through his site, I even got some extra. But the first book sold 11,500 copies, and there was a second edition. It was a rewrite, sold 8,000 copies. And then I decided to make it easy for people to obtain the book, and now I've started writing books on LeanPub. LeanPub is an online publishing format where I can write a book in markup, simple markup. I put it on Dropbox. I hit a button on the LeanPub site, and automatically a PDF is generated, an EPUB file, and a .mobi file is generated. And you have a buy now button, but I've set the minimum price at $0. So without registering, well, you can obtain the new books without having to pay for it. If you register, then every time I have finished a new chapter, I can make a new version, and then I can hit a button so that you are informed by mail that there's a new version available. So the ABC of PDF with iText is the first the first new book I'm writing. It's more a simpler way to read the PDF specification. I told you that the ISO 32002 will be 1,200 pages, and here I try to explain PDF using simple examples, using step-by-step examples. There are some upcoming titles. Create Your PDFs with iText is the next one I'll make, and that will explain the high-level objects. The ABC of PDF uses iText, but is more about PDF than about iText. Creating PDFs with iText will be more like the iText in Action books. Updating your PDFs with iText will be about forms and the watermark example you've seen. And then Sign Your PDFs with iText is a rewrite of the digital signatures white paper that I already published a couple of years ago. So, thank you for attending to our talk. You can visit us at booth 5712. I'll be there quite often too. And I see that we have still a couple of minutes for questions. If somebody has questions, you're welcome to ask them. Yeah.
In the current version, you have a nice mechanism for auto-generating PDF from structured swing elements, for instance, tables and stuff. And sometimes that can be very useful. Do you plan to support the Java text components with the same functionality?
So for the rest of the audience, iText can create PDFs from a high level using paragraphs, but also from a low level, saying using PDF syntax like show text and move text. And we've built something on top called PDF Graphics 2D. So you have the Graphics 2D object in the JDK, and we've implemented this using PDF Graphics 2D so that if you use Graphics 2D syntax, you can output this to PDF. It isn't always flawless, I have to admit, because you have to translate Java syntax to PDF syntax. JavaFX, so we've doubled the number of employees this year, and we have a JavaFX developer now, Benoit. And so it's not on the roadmap, but if there's sufficient demand for it, then yeah, that's something we can look at. The demos at our booth are in a JavaFX application, so it's certainly something that we'll look into. Yep. I just can maybe I can. Mm-hmm.
I want to add an image.
Uh-huh.
Does that image follow some standard or any?
So you've briefly seen the structured tree root. Yeah? So in the structured tree root, it has the complete sequence of all the objects that you add. So the difficulty of adding an image to a document that is already PDF UA is you can't just add it to a page. You also have to refer to that structured tree root. So you also have to add an entry in the structured tree root at the correct position. So that can be a challenge. Maybe.
Are you referring to the image format itself, like if it's a JPEG or a PNG? But the image format shouldn't matter. But as Bruno explained, the difficulty is in if you add the image or whatever content, it will also have to be inserted at the correct place in the logical reading order of the content.
But if the image is like a watermark, then this watermark is an artifact. It doesn't make part of the it doesn't make part of the logical structure. Then it's simple because artifacts don't need to be added to the. So it depends on what the purpose of the image is. If it would be something really part of the content, like we had the fox and a dog, and you want to add it to the content so that you have alternative text, then you need to add it in the structured tree root too, and that can be a challenge. If it's just a watermark, then it's no problem whatsoever. You just need to be sure so that you mark it as artifact, because in a PDF UA document you can't have any content that that isn't quantified in some way. So you need to be able to identify the object. Mm-hmm. There are different standards, but they share some things. So PDF UA, you have level A and level B. Level A is the accessible PDF A. So, yeah. So there's a limited set of image types that can be stored in a PDF. Like, for instance, if you would add a PNG to a PDF, it wouldn't be stored as a PNG. And if you respect well, you can't add a PNG to a PDF, but if you use the image types that are supported by PDF, then they are supposed to be consumable in 30 years and 60 years. So PDF-A prevents, so in a PDF-A, you are not allowed to use algorithms that are, for instance, proprietary from somebody. You can only use the open, the specifications that are open. More questions? Okay.
I've never used INTEC before, so it's going to be a dumb question. But is there any like style sheet functionality to make styling your PDF simpler?
There are different options. One option would be that you create an XHTML file, and that you define a CSS. One of our customers, they need to, it's a printing shop, and they print high volumes of invoices and quotes for their customers. And these invoices always have the same structure. So they provide the data in XHTML, and then every different customer has a different CSS. One with the blue logo will have the tables will have blue backgrounds. One with the red logo will have red backgrounds. So that would be one option to do this. But of course, HTML isn't really a good format to define a layout. So I call this like the poor man's solution for high volume production. Otherwise, you have all these levels that go to the really lowest level of where you write your own PDF syntax. No styles there. And then you have the high-level objects, the paragraphs, limited styles, and then you have the templating like XFA or XHTML plus CSS. Yeah. There are different parts to this answer. So you've seen that when I opened the PDF in a text editor, I had to start at the very end to find the start of the cross-reference table and then find the objects. There's something called linearized PDF. The more common name is PDF for fast web view, where you reorganize your PDF, adding all the objects you need for the first page first, and then you have a cross-reference table that has links to these PDFs, and then every page has it builds up like that. And so when you download the PDF, you can view the first page first because you have all the necessary information. You have all the fonts for the first page and so on. Creating such a PDF in a streamed way is difficult. Normally, you create a PDF, and then you reorganize all the contents to make it ready for fast web access. Why? Because if you would stream such a PDF, you create a subset of a font that is needed for the first page, but you can't already send this subset to the viewer or to whatever, because maybe you need to extend this subset. Maybe there's glyphs that need to be added that are not in the subset of the first page. So that's one problem. As for streaming PDF, the main reason why I wrote iText in the year 2000, so I published iText for the first time in the year 2000, was because I didn't find any library or tool that was able to create PDF in a web context. I wrote my first PDF library in '98. Back then, PDF was something for the desktop. Somebody was sitting at the desktop and created his PDF manually. And I worked for a university. I needed to create PDFs with as many pages as there were students, and we had 30,000 students. I needed to create a document with 30,000 pages in a web application, so it had to be fast. And what I did was all the existing tools used the MVC pattern, Model View Component, where they created first in XML. And once they had all the data in XML, only then they started creating the PDF. I broke this pattern and I used a different pattern where as soon as I have sufficient information about the page, I stream it to the browser so that the timeout can be avoided. And, but of course, you can't view this PDF when a page is sent to the browser because I keep in memory the cross-reference table. I keep in memory fonts that need to extend. And so I hope that answers the question. I don't know. If not, we're at our booth in a moment. Okay, I see that people are waiting for the next session. So if you have questions, come and find us at our booth.
Thank you.